purpose of this engine. With this new engine, we will have more torque power, more efficiency, less friction, less heat, no pistons, more horsepower, and easy to replace parts. Let's remember some aspects about torque power. Torque is the tendency of a force to rotate an object about an axis. According to the torque equation, magnitude of the perpendicular force to the lever arm and the distance is directly related with the magnitude of the torque. As you see here, in internal combustion engines, we obtain great force during combustion, but greater amount of torque power is limited because of the short distance of the lever arm, and it is not possible to make this distance much longer. Think about a door. If you try to open a door by pushing on the door near its hinges, you must apply a larger force, but as you get farther from the hinge, you can apply a smaller force to make the door swing. In internal combustion engine, you see the distance here is very short. In my engine, even I put the combustion chamber same distance to the main axis. You see the distance much longer. It could be even designed longer if needed, therefore it provides us with more torque power. At number 3, you can see how fuel injection and air-fuel compression will work. At number 4, combustion takes place. We can put the fuel injection and spark on the revolving head, or we can put them to the side walls. Here we can see the combustion. Note that during combustion, while revolving head rotating, wings has a little bit backward motion. On this slide, the yellow suspension part that we see could either be cut off or it could be shorter if we change the structure of the wing system. On my engine, I changed the wing structure. You can see from the slide, presentation is the side view. Note that inward curving is closer to the axis and asymmetrical. If we can make the end plate part as shown here longer, we can obtain higher air-fuel compression ratio. Also, revolving head can be designed as bottom side flatter, and the hole can be designed instead of a groove. With designing a hole, we can make the end plate part which is going into this hole longer. As a different alternative, a 3-wing model can be designed and each of the wing slide on the gear shaft to form a combustion chamber. Compression ratio will be higher in this model. Important thing in this system, each wing slides on a gear system and 2 of them lock down with the motion of the revolving head while making a combustion chamber. Gear system mechanism also has connections main shaft's gear system. We can also design a hinge system at the connections between side carriers and main chassis. We can easily separate side carriers and wings from revolving heads. This is my first trial prototype, which was not completed. I did not replace any fuel injection and spark sensors. A mechanical system also can be used instead of the sensors. These are the wings and the sidewalls. To lubricate the engine, tiny pores can be replaced on the inner side of the sidewalls and on the edges of the wings. Then all needed is to pump oil to these pores. For better sealing, inner side of the sidewalls where the combustion occurs could be done a little thicker. Also, edges of the revolving head and wings could be sealed with a sealing material. 2 fans can be replaced at the position of A and B. Fan A supplies fresh air for the combustion, and while fan B provides vacuum effect and it is used for the exhaust. Note that at high speed RPM, engine would cause a gyroscopic effect. After further evaluation and experiments, this engine can be designed to meet optimum results. I am very excited about this engine project. I hope to receive your valuable feedbacks and your recommendations and complete it with your experience. All feedbacks are welcome. You can contact me through my email. Thank you for your time and support.